Good afternoon, everyone. My name's Renee Stromberg. You've probably got the email invite for me for this event. I'm the head of TAILF Marketing, a Cisco company, and I'm delighted to have this presentation, the opportunity to have one of our key customers present their strategy for next generation SDN and programmability. And with that, I'll let Ehab give his own presentation.
Thank you very much, Renee. We really appreciate the support from you and all the TAILF team. And hi, everybody. Thanks for taking the time. There's so much more exciting booths outside, you know, the new Samsung phone, everything else. So I'm glad you made it here. I have a few slides that I'm going to walk you through here, which is what's our strategy as Equinix, but also what do customers want and what are we doing with TAILF. I know we can do Q&A, correct? So if you want to, you can ask questions anytime. This is casual. This is lunch while we're all here. Okay? So so here's the agenda. We want to quickly talk about the technology trends that led us to the point to use TAILF and also to deploy our cloud exchange and our whole platform called EPN. We want to talk about what's the Equinix value proposition, which is, okay, so we have the technology. Why is that technology good? What are we using it for to create some benefits for our customers so we understand what our end customers see? And then the last one is the collaboration we have with TAILF, okay, which is a Cisco company. So the first thing that's happening that we see ourselves is that there's a massive transition happening in the industry to a massive mobility platform with billions of devices that are all now like computers, programmable with applications that can be on them across the globe. And then on top of that, at the same time, is you have Internet of Things and potentially soon enough trillions of devices that would have sensors around it. So between the Internet of Things and mobility, the amount of data and amount of access points that are coming in is so enormous. But it's not like the old internet where it's just looking for traffic. These things are looking for specific applications, looking for performance. Some of them are high bursts of capacity. Some of it is very little capacity needs that transmit over long times. So the bottom end is that when this amount of data comes into the application, which happens, most of these applications happen to be in our data centers, all that data has to be processed, summarized, and something has to be done with it. The best example is like my Tesla, which I love that car. You know, it has new features like autopilot. So the autopilot, you okay? Higher? You can hear me better. Sorry about that. So the Tesla has features like autopilot that draw so much data from sonar, looking at potholes, looking at anything like that. All these new smart cars now draw enormous amount of data with every move, and that data all has to go back to some application to process it. When that application gets it, it has to compare data with multiple databases and all kinds of clouds. And so that real-time analytics that connects to social, mobile, to like mobile payment, all these things have to happen in microseconds, milliseconds, because the data gets processed and fed back to the user real time. Something like Uber, when you look at it, you can always see where the driver is at all times. So with that in mind, the processing of the data and the cloud edge now has to be sitting in the middle between networks and clouds and be able to pull the data and make all these real-time analytics. That's a huge change from anything we had before, because before the database could be somewhere in the back. The application, you know, may take hours to do a batch job, or overnight maybe to do a batch job versus, you know, millisecond processing. You know, so we're showing examples of how all these different clouds for business customers here. So what's the value proposition we do? So what we're trying to do is solve for high performance and high security connections that enable all these kinds of processing and business applications that come with it. The second thing we're trying to do, and offer SLAs to go with it, because the public internet is not going to be good enough for these high performance applications. The second thing we're trying to solve for is that people need to go to multi-cloud now. One cloud is not enough. The average enterprise customer has somewhere between 40 to 80 clouds they need to use. In many cases, they have to add a new cloud application every week. So like my team alone, just last week we said we need to use one more application called @Task that is a social mobile-based project management tool. So everybody's adding a new app every week almost in all these companies, and they need to be able to quickly connect to all of them. The old model of saying, okay, I want to connect to this application, and it's going to take me 120 days to order a circuit is not going to work. They need to be able to do it quick. Single port to multi-clouds, because what we want to do is bring significant efficiency to the customers. It's impossible for enterprise customers to be able to connect, you know, to every cloud with its own circuit, its own port, its own IP connection. That is not only difficult and expensive, but it's unmanageable, because you would have to have a huge staff who manages that capacity and that, you know, coordination. The last two things we're solving for is that we have to go global, because most people are launching the applications globally. So we launched our cloud exchange in 16 markets across the globe, everything from Hong Kong, Singapore, to London, Frankfurt, to, you know, across all of the US and Brazil, Canada. By doing that, people will be able to get the same consistent performance across the globe. Most people who are launching an application or Internet of Things, like a, you know, like a big construction firm or something, they're all global, and they want the customers to get to them globally everywhere. They all want, the last bullet is the biggest promise of SDN. When we all talked about SDN a few years ago, everybody here talks about SDN probably from before. When we all talked about SDN a few years ago, we kept talking about it as efficiency with NFV, but the reality, what people really care about SDN now is agility. They just want to activate quickly. The savings will come, no doubt, but it's the ability to activate quickly and have agility and automation is what everybody cares about. It's not just with activation, but with service assurance and monitoring. I went fast. Does that make sense so far? It's a whole new world. If you have to support your customers in this new world, where they can get to you from 1 billion or 2 billion mobile devices across the globe, the only way to do it is to have your business model on an application that sits in a data center between all these hundreds of clouds, and that application has to be able to process all the data in real time and dish it back, or nothing will work. Or your customers will be frustrated, or you'll tell them, I can't make it available via mobile. And anybody who does that will lose their business model long term, and somebody else will come and disrupt them, like, you know, somebody like Uber did to the taxis. So that's what the world is, and that's what our customers are looking for. That's what we're solving for as a company. I can tell you we have a lot of exciting customers who are consuming those capabilities. Make sense? Okay. So what did we do here? What we did is, in addition to the public connections, and if you know Equinix's history, we have the largest public exchanges in the globe. For the last 15 years, we connected people together via IP peering. Everybody's familiar with that. This is where the internet connects at Equinix. So now what we want to do is we want to make sure the cloud connects at Equinix. And so we created a new cloud exchange for private peering, for private, secure connections that enable the kind of applications for business customers that I talked about a little while ago. And that cloud exchange, that platform is what we're using Taylor for. It's the platform that our customers are buying, and we have a lot of adoption. We already have over 100 customers signed up for our cloud exchange, and we see tremendous growth in the connections we're getting from enterprise customers. So we've really seen a very meaningful growth in that platform. And if you don't know about Equinix, this is the only slide that may look like a architecture. I apologize. We're a leading global data center companies. We have 4,500 customers. We have data centers. We have almost 1,000 networks in our data centers, so you can get to anyone, anywhere across the globe. We are in 32 markets on 5 continents and I think 18 countries. Therefore, we have a global platform that people can come in, collocate the data, and more importantly, connect to everybody. It's the future model for enabling your business applications in a way that you can quickly reach those massive mobile and social platforms that everybody's trying to get to. Okay. I think I bored you with that. Okay. So what is cloud density? What we feel like you have to have a meaningful footprint of clouds in your data centers for this value proposition to work. Because if you can't quickly connect to the cloud and move massive amount of data between different clouds and in and out, then you know, number one, you'll never achieve the economics, and also the performance will not be anywhere close to where it needs to be. So in our data centers, we have over 1,000 clouds and IT companies. That's the biggest cloud density of anybody in the world. And what we have done is now connected the largest players. We have Microsoft in 16 markets. We have Google in 15 markets. We have IBM SoftLayer in 9, AWS in 8, and now we have Cisco as our latest partner coming into 16 markets. We have a lot more. We have 100 customers, as I said. We have a lot more than that you can see some of the logos behind me, and many more. But we feel with the biggest players all connected to Cloud Exchange, now this is the only place in the world where you can go global and go to Google, Amazon, Microsoft, IBM, Cisco, and move data in and out on a global basis within, you know, microseconds. But what everybody wants is the ability to do that automatically, quickly, and be able to control the performance and quality, which is what we solved for. Makes sense? What you'll see from us at the end of 2015 is hopefully hundreds of clouds and hundreds of enterprise customers. That's what we're aiming at, and we definitely see significant momentum in that direction. We hope by the end of 2015 we would have solved the biggest challenges of how you connect to the biggest network providers with things like Cisco Intercloud and others, and how we also solve how enterprises can connect with a single port and go to hundreds of clouds, one IP address at a time. Our biggest focus is to bring application level performance to people, because at the end, people don't care about any of this stuff. They're just trying to make the application work, either Office 365 or Google Drive or anything like that. So that's the path we're on. I think I'm going too fast, but it's okay, correct? Yeah? And once you do it, so here's some numbers. So you see, once we connect, people who are connected to Microsoft Azure, these are all the different types of performance metrics we measure. We could see that anybody who connects to Cloud Exchange directly is getting almost a 36% improvement in performance. So that's a huge number for people. I mean, that changes how you write the app. That changes almost the business model. And this is with just a gig-e connection. So think in the future when people have to have 100 gig and have to move massive data, these numbers will just explode in volume. We're measuring all the different clouds as we speak. We have something called Solution Validation Center, where our solution architects work with customers and connect them. And we're going to have the same numbers for Google, IBM, et cetera. But right now, there's a huge performance improvement that people are seeing from that ability to connect directly to Cloud Exchange. And this is probably the most popular cloud for enterprise customers right now, which is the Microsoft Azure, who's one of our biggest partners. So our Cloud Exchange that I talked about allowed people to come in with a single port, do either layer 2 or layer 3 connections, and they can use portals and APIs and get speeds all the way up to 10 gig and beyond. The big secret here is the API, because with an API you can activate in 5 minutes. So again, I believe we're the only ones who allow you to connect to Microsoft Azure or AWS in 5 minutes with an API to create a virtual cross connect on the fly. The fact that you do it with an API means the developer can do it as part of the code. You don't have to call another person to do it. You know, as you're writing your application, at the end of it, you'll write the commands for the APIs and activate. So now you have full control over the stack from the top to the bottom. Okay, so how is Cisco helping us? So first of all, I want to introduce our platform, which is Equinix Programmable Network. This is our SDN platform that we built to enable our enterprise customers. And we announced it in the press earlier this week. And you'll hear more about it, because this is the platform our customers connect to, and will continue to bring more features to that platform. It is our service layer that is behind Cloud Exchange. Our product is Cloud Exchange, but the EPN is the technology platform behind it that makes it happen. So EPN, customers connect with those APIs that I talked about directly to our EPN. And then from there, what we do is we build Yang service models. So let me take time to explain how the world changed so dramatically for us once we started to use the NCS. To introduce a service like layer 2 activation with Microsoft or AWS, that may have taken months of work with somebody like an equipment provider, because you had to build additional OSS systems, and then you have to go to the equipment providers to build the features and the software. You have to make the two work. You have to test between them. You'll find bugs for months, and you'll keep working back and forth. It's two different systems, two different processes. Nobody can introduce a product in less than 9 months in that process. I can tell you, I lived that for the last 20 years. And also, all our telco partners here, all the service providers, still do it for the mass majority. Once we started to use NCS, somebody in our team can write a model for something like layer 3 service in literally 2 weeks if we want to. And then that model, we just download and use the Cisco, Cisco tailf NCS, and once it goes into there, the tailf takes care of downloading those instructions, taking that model, and then making it work directly to all the different end devices that tailf have written plugins for. And for the most part, everything we want has plugins for, and we continue to ask for more. It's called plugins or what? Drivers, okay. But the bottom line is we can move on to build the next Yang model, because we need to keep up with all these clouds. We need to keep up with all these enterprise customer needs. So we need to continue to create new models. And then once we do, we will just let the partnership we have with tailf is that they continue to help us create the new capabilities we need, so we continue to download them. The second big thing that's happening is because we are using netconf, to the network devices. This netconf resolves so many of the problems that we as an industry had with CLI and with all these different protocols before to download into the devices. Netconf can, in a transaction basis, go to all the devices in the network at once, and all of them will accept and go. In an older world, you have to go to the first switch with CLI, and then you had to figure out how the second switch works and how the two work together. So again, just downloading the instructions was never real time, so the service activation could never be real time, because you could not talk to the switches in anything less than hours, most likely, and you had a lot of coordination between the switches. So therefore, you had to preset your service, and it could never be dynamic. But now with netconf, it is dynamic, because you can definitely burst all these transactions to all the devices at once. So those are massive changes in the industry. I have to say that to me, this is what my best description of this in English terms, as I always like to say, is that how the developer used to need to know C code, C++ and every line and everything, and all these foreign languages nobody would understand. And now developers don't have to know that. You can have any young kid come in, grab code off the web, and like if you go to one of the Google conferences, you can create a whole app on your mobile devices with video across the world in like half an hour. Why? Because you can grab code that's pre-done by millions of people before you and slap it together and create an application as a developer. I would say for the network people, we are finally living that dream. Finally, because you can create your Yang model, and then you can download it, and something like tailf, you could download it to the devices. This thing is just going to continue to speed up, and the pace of development for new services and the ability to create them will only speed up. Now, what it did for us is we had to go to a DevOps model, because that's the network design and development has come now. It's the same network design and development we've always done, except now it's a DevOps model where you get your hands dirty. You don't put it on a PowerPoint that circulates the place. PowerPoints will probably be dead, in my view, when this thing takes full effect, because by the time you created the PowerPoint, you could have done probably the product, and you could have downloaded it and tested it and seen if it works, correct? By the time you're waiting to view that PowerPoint. So what is our design principle behind these platform EPN? This is what we call our platform. One is agility. We want everything to be automatically available, and we're going to continue to work through all the resources we have to make it agile, automatically available for everybody who can use it anywhere. Number two, modular, because we need to continue to support more services on a module by module basis, and that's because our customer base is diverse between clouds and networks and enterprise customers, and we have a lot of ecosystems like AdIX, et cetera, coming up, so we're going to have to continue to create more things. It definitely has to be multi-cloud, which is the biggest value proposition. I also would tell you that's the biggest challenge of them all, because multi-cloud means you have to solve not only for the network and IP address management, but you have to solve for authentication, customer service keys, customer ordering, security, all of it in a uniform way where the customer can get a single port and be able to do it. And the last one, it has to support multi-vendor, because the network, we have at least 6, 7 primary vendors and another 6 or 5. But we're going to focus on 6 or 7 primary equipment and switching vendors. And in the future, as we continue to add, generic hardware and generic optics and anything else that comes out in the industry, or things like Intel chipsets for IoT, all of that will become manageable via the same platform. So what is the benefits of, this is my time to give Tailiff some benefits here, yeah, after we talked about ourselves for so long. Okay, so the first thing I would say, development agility. I mean, not only agility because we're able to use Yang and how it does, the system itself does a lot of the overhead we don't have to deal with. So as you can see, NCS gives us the authentication, access control, accounting support, all the stuff that IT people do. We don't want to deal with that. All of it NCS does for us, and therefore we just focus on our business, which is what is the product we're trying to sell and how we design it. And then the second thing, multi-cloud, because of this transaction management, we actually can do it. It's part of the NCS system that allows us to use NetConf and go to all these multi-devices at once. So again, NCS solved a lot of the issues we would have had to solve, and we're not interested in solving because it's part of the basic system workings here. And then the multi-vendor strategy, I think the history of this company, Tailiff, and all the capabilities they've had, and the fact that they have all the drivers for the key vendors enables us to go fast. There's no vendor we've asked for that's not available, and if one is not available, I can tell you, we really appreciate what Tailiff is doing to turn it around almost immediately. So we feel very comfortable with our ability to continue multi-vendor. And I would say Cisco committed that Tailiff would stay multi-vendor and open, and that is very important to us. That's very important to us for anybody watching from Cisco. Modularity, again, the same thing. The way the system is designed, we can continue to get modules and be able to use them. So it's a fantastic partnership. We really appreciate what we're doing together. A lot of people in the industry are doing it. And I think you'll hear from some people also on the panel later at 4:30. We have many of the biggest players in the industry. We're all coalescing around Yang and NetConf, and also, what we're doing with NCS here. Okay, so what's our future work? So we ourselves are asking vendors to go to native Yang and NetConf. Although Tailiff does that for us today, we still want to use NCS, but we want them to go native below it so it's more efficient, more effective. And we're getting a lot of support from the biggest industry players to go native on their devices with that. A lot of them already do it, actually. But second thing is we are involved in IETF with a lot of biggest players of the world who are pushing that. And we are going to continue to push on standardizing these models. When we standardize the Yang models, things will move even faster. Today, every one of us has to create. When you go to standard Yang models, you really can go on the web and pull layer 3 VPN in 2 minutes and you're done. You don't have to even develop that. So this thing is going to accelerate in terms of agility in a big way once that. And we have people like Google and others, some of the biggest players are behind some of those discussions in IETF. So we feel comfortable that there's enough momentum in the industry behind that automation. And then we want to scale out architecture. So we want to continue to expand and scale. And then the last thing is we want to get to the point where we do service chaining. And by the way, I don't think anybody in the industry knows what service chaining is. Nor do we know, nor do we believe we understand it. But it's the biggest buzzword. But at some point, we want to figure out how third parties like security companies or storage companies can insert themselves dynamically into the connection between an enterprise or a network and a cloud, and be able to offer a specific service dynamically for a specific flow. And I really don't think anybody knows how to do that now, no matter who says what, from our perspective. So, but it is on our roadmap, and we need to figure out what that looks like eventually. Okay, so hopefully I downed you where you can't ask any questions, but if you have one, I'm happy to answer. Anybody, any questions? Hey, Nan.
Yeah. I'll ask a question. So you talked about the agility, the talked about the modularity and the things that are coming.
Yeah.
How long did it take you to get from kind of ground zero to the point where you can start achieving some of the agility benefits? Can you share with us the timeline that it took us to get to that point?
Actually, we moved really fast for our. What happened is we started to deploy Cloud Exchange. We announced it in April, and then we started to work with Microsoft, and we quickly realized that we needed to launch Microsoft by July. So we had April to July, not only to deploy the platform in 19 markets globally from zero, but to also do all the automation and architecture to connect to Microsoft. And that's where, the team, our team here, Terry and her team, decided to use Taillift. And I tell you, if we didn't use Taillift, we would still be talking about it. But the fact that we used this platform, we were able to launch July with Microsoft, and we had the full automation we were looking for by July. So this is unheard of to have we had no network equipment, no service, and April to July we had the equipment, and by, in all these markets, and the automation and the service where people were able to order it. And we hope to continue that path because we have a huge pipeline that we need to keep going with. You couldn't do that with a standard OS. You don't even have an OSS system strategy yet, probably, if you were still doing it with standard OSS. Hey, Nat.
Hey, you have kind of straddled both worlds now in data center. How do you see the things that are converging in terms of telecom networks versus cloud or data center networks?
I think the traditional data center model is the same, Dan. What it was before, in my view, is that peering between networks for the IP layer, because the biggest issue was how do you get content like YouTube to the network and how you get networks between them to get IP traffic going for IP peering. And so the same model is the same. The big difference thing here is that now there's a need for peering for the cloud and for enterprise customers. So there's a whole new set of peering that didn't exist before that has to happen, which is how do you allow secure, high-performance, enterprise-specific with authentication traffic to move between networks and move from networks to cloud. And the big change that happened there is that about a couple of years ago, a year and a half, or 2 years ago almost now, AWS said you have now direct access. Remember, once you started to have direct access to the first cloud, it just escalated from there, Microsoft next. Each one of them said you can have private direct access, very similar to the beginning of the internet where people were trying to find each other, this one network with that. And so I don't think the model changed at all between network and data center. The change is we have a whole new set of peering for private and cloud access with security and authentication that did not exist before. Okay, any more? Okay, oh, go ahead.
Can you talk a little bit about the ongoing monitoring of once you've done the build out, et cetera, how you approach that challenge?
Yeah, very good. That's an excellent question also. Our view is that all this just solved the activation. And what the industry is missing, all of us, is the other pieces of the service assurance and analytics model. So you need service assurance, you need monitoring, you also need to be able to do analytics on the fly using things like Splunk, be able to pull data and do, detect. Those tools don't exist today from anyone as far as we're concerned. So we are working with Taillift to see what is possible and what, that's one of the things we're working on. I also can tell you at the same time, the same DevOps model, we're trying to figure out our own tools, and we're going to make them available sometime in 2015. Those APIs that we talked about before, not just for activation, we're going to provide APIs for service assurance and monitoring and custom health of the network and traffic data. I think most people will either use their own OSS systems or have to develop something for the monitoring until there's something more standard in the industry that everybody can use. It's definitely the biggest challenge to solve right now. And I think that's the biggest challenge of SDN. It's not the activation, it's how you manage it. That's why I was making my comments about service chaining. So if we have immaturity of the tools for just one platform, how do you service chain 10 of them with no monitoring tools and provide any kind of high performance? So it's a big issue. We're all working on it. Hopefully next year at this time there'll be good answers. Okay. Well, thank you guys very much. Thanks for listening. Thank you.